welcome to Simcast, a podcast brought to you by the Society for Imaging, Informatics, and Medicine. Greetings, Simcasters. With the myriad of information systems that comprise nearly any healthcare institution, whether it is a small outpatient clinic or a large tertiary care center, systems that we use rely on interoperability. In today's episodes, hosts Mohannad and Prasanth will speak with Brad Genereaux about standards and interoperability. Brad is a frequent guest of the podcast and was recently featured for his work on the white paper on AI interoperability. He currently serves as Medical Imaging and Smart Hospitals Alliance Manager at NVIDIA and serves on multiple committees, working on the DICOM HL7 and IHE standards, just to name a few. As Prasanth aptly put it during the discussion, standards are the thing you think about least when systems are running smoothly and communicating properly. Nevertheless, the discussion highlights the critical importance standards play in making our disparate systems work together and ultimately provide the streams of information that are required for complex decisions utilized in the current healthcare information age. Please enjoy this episode. Welcome, Brad. So your chapter is on standards and integration. So to set things off, can you describe to us how standards impact all of us and the benefits that can come from following these standards?
Absolutely. It's incredible how much standards are being used in hospitals today. And any trip to the hospital, you wouldn't even have a full appreciation of what is happening between different systems. I remember once I was in the ER many, many years ago, and just sitting in the room and thinking about the wires above me and the transactions going back and forth over the network hundreds of times a minute on all the different types of information from different information systems are flowing back and forth. Standards help us with all of our different applications so that they can communicate between one and another. So for example, when a patient gets registered at a hospital, or an order is generated on a patient, or a result has been entered in, or we acquire images from a patient and we need to get it from the acquisition modality to the PACS, to the VNA, we need to get the reports to the referring physician. All of these are using standards to describe what has happened and communicate that to the other systems downstream. Without that, the amount of effort and time to go into connecting these different systems and helping each one understand one another would be astronomical. And so we're able to get a huge advantage of getting these systems ready and talking to one another without having to spend a lot of time really thinking about it. They just connect to one another. And this is thanks to the last 30 years of standards, really, for lack of a better term, standardizing the way that these systems talk to one another.
Yeah, I'd have to say that standards go even deeper than that, because if you think about the cable that it's running on, Cat5 cable or Cat6, right? Those are standards, right? The frequency of the electricity, it's a standard as well. The plugs that we all use, they're NEMA, blah, 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 right? Whatever they are, that's a standard. The light bulbs, they're standard. There's so many things in our lives that are standardized that build upon build upon build to the point where, now these standards for communicating back and forth have been built on, okay, well, what's the physical medium that they're communicating on? Okay, we need a standard for that. What's the next level? What's the next level? What's the standard for the wire composition, if you will, right? I'm sure there's a standard for that as well. So these standards go way deeper than most of us think about in our day-to-day lives because it just works, right?
Just works. Yep, yeah. Exactly. Yeah. And what's really interesting to think about is when you are designing a system, as you design it, you can decide, well, what is the thickness of the wires and what will system A say to system B? But the minute that you leave that realm of control where you can control the inputs, the outputs, and are working with external actors in that particular workflow, you absolutely need to define those rules of engagement between each of these, what to expect, what to send, you're going to receive when you get a message back. And it's super important that as an entire ecosystem that we're thinking about these kind of inputs and outputs.
So that leads me to a question. In case any of our listeners are not aware of what a standard like HL7 actually means, Brad, can you tell us what HL7 is and what motivated the creation of this standard?
What HL7 is and what motivated it as a standard?
Yeah, absolutely. In case any of our listeners aren't aware of what HL7 is, can you just quickly recap what HL7 is and what it actually does in healthcare and imaging IT?
Sure. Yeah, absolutely. So HL7, which stands for Health Level 7, is a standards development organization, an SDO. What HL7 does is define the transport mechanisms of health data from one system to another. And so, for example, if we have an EMR and we have let's say a laboratory system, HL7 describes what the message looks like when it comes from the EMR and how the lab system will take that in. What protocol does it use? So, for example, we'll talk about HL7 version 2 or V2, and we'll talk about FHIR as the two different versions. We'll talk about that in a few minutes. But for HL7 V2, we use the MLLP, the minimum lower level protocol, to send data back and forth using a specification that describes this is the event that's happening. Patient is admitted, order has been created, results are being sent, patient has been discharged. It's all event trigger driven from one system telling another system what's happened. That payload of that message would include, for example, different segments. We would find the patient ID segment where we'll see the patient's full name, their birth date, their address, their family physician. We would see a patient visit piece of data, which tells us what ward they're in, whether they're an inpatient or an outpatient, how they arrived to the hospital, what department are they going to go and see. An order level information will tell us if their lab order has been done, if it was a panel or what type of blood tests were being done, to give that to the lab system to be able to prepare to process the blood from the patient. So that's what HL7 is doing in this case, is defining that message from one system to another.
Brad, you mentioned a little bit about FHIR and HL7. I'd like you to dig into that a bit more, but also, can you explain what versioning means with respect to HL7?
Sure. No, absolutely. So as with the course of any standards evolution, we have seen HL7 version 2, and actually version 2.3 or 2.5, 2.5.1. What this describes is the exact structure of that type of message that we're sending. There's also version 3, which is an XML-based standard, but it's not in common usage. And then we have FHIR, which you could equate to being version 4. And rather than using the MLLP protocol, which I mentioned a little bit earlier, it's using RESTful technologies, well, as one means of getting data from one point to another. Both the sending system and the receiving system have to use the same version in order for them to understand one another. So, for example, you couldn't send from an EMR a version 2.3 message and then the receiving system only being able to understand a FHIR message. They have to match version from the sender to the receiver and back again. There are things that exist that can translate from one version to another, but it's typically better if both systems directly support that particular version. But all it really changes is the way that we put the healthcare data in what fields and what separators and in what structure. So version 2, as I said, is what we call the pipes and hats format. And in FHIR, we're using either a JSON or an XML-based variant, or there's one or two others as well.
Thank you, Brad. And while we're in the spirit of just doing introductions of the basic standards in healthcare and imaging specifically, you want to quickly cover what DICOM is and how DICOM actually enables interoperability in the imaging workflow, like acquisition, transfer, etc., as well as how each of them fit, DICOM versus HL7.
Yeah, absolutely. So DICOM, the Digital Imaging Communications in Medicine, is also a standard. It's an SDO held by NEMA. And if you think about what HL7 does, which is communicate metadata about the patient, like textual data about the patient, specific around admissions and lab results and reports, DICOM is all about the imaging components. So DICOM specifies both the imaging payloads, the pixels or the representations of pixels, as well as the metadata that supports those pixels. So what part of the body was this image acquired from? What was a protocol that we used to acquire these images? What was the technician who operated the equipment that acquired these images? Who's the patient identification, all of those sorts of things that are tied directly to the imaging payload. It also started around the same time, back about 30 years ago in the late 80s. HL7 was also around that same time period. And again, it came from a need of being able to have our modalities, X-rays and CTs and ultrasounds, as we acquire images, to be able to store them in another system in a standards way. So it's not just about, I've got this CT from this manufacturer. I shouldn't need to have software from that exact same pipeline, that I could use different applications to go about my business. I might need to have a different viewer. I might need to have a 3D reconstruction that would also take advantage of using that data to reconstruct images from there. But really, it's about interoperability of all of the images.
So, Brad, while we're on a roll of describing all of these standards in this alphabet soup, we might as well roll right into IHE and what makes that different than other standards bodies like DICOM or HL7.
IHE, unlike HL7 and DICOM, is really around the standard of standards. So just take a quick step back. HL7 is all about the metadata about the patient, textual data, discrete data of orders and reports and patient condition. DICOM is about imaging. I might use other standards like HTTP for RESTful services. I might use OAuth or SAML for authentication. So there's other standards that are out there that is used to do the workflows that we find in healthcare. But putting it all together is the realm of what IHE does, right? It's not enough for us to say, hey, I've got a PACS that talks DICOM and I have a modality that talks DICOM, therefore they work together. That is entirely not true. Because if I were to take, an X-ray that does DICOM and an ultrasound that does DICOM, I can't put those two things together really, because it's not a very cohesive workflow. What we need is a body that oversees the workflows that we do in healthcare and pulls in DICOM and pulls in HL7 and pulls in other standards to actually do something meaningful from a workflow perspective. This is what IHE does. Integrating the healthcare enterprise, IHE. What it does is it defines the profiles, the transactions, and the actors that we would do to satisfy a particular workflow. So for example, a scheduled workflow describes the steps as I'm acquiring images for a patient. It relies on HL7 for the order information. It relies on modalities for the imaging information and pulls it all together into something cohesive for a particular workflow. So that's what IHE does. As I said, it's the standard of standards. It's the meta standard. It's actually taking other things that are out there and constructing meaningful workflows.
Thank you, Brad. So now that we've covered, as Prasanth called it, the alphabet soup of IHE, DICOM, HL7, FHIR, let's maybe move away from acronyms for just a little bit and also talk about another practical example where standards play an important role without necessarily being, code and cryptic messaging, driven. Do you want to describe to our IIPs how a DICOM conformance statement can be used in real life?
Absolutely. So DICOM conformance statements are a fantastic resource that if you go to the manufacturer of your applications or of your modalities, you can go in and find this information. And you just Google DICOM conformance statement for whatever piece of equipment or software you're looking for. It's a document that every manufacturer produces that describes how that particular software or hardware works in the world of DICOM. So for example, you can get a sense of if the images are coming compressed or uncompressed. You'd get a sense of, does it talk DICOM or DICOM web? You can get a sense of the types of things that's supported by that particular unit. And it allows you to match capabilities of, let's say, your modality and your PACS. So does your PACS store pathology images? You could look at the conformance statement and see if the particular pathology subclass is listed in that conformance statement. You could really, it just allows you to understand and manage your expectations for these different pieces of hardware and software in your ecosystem of how they would talk to one another.
I want to ask you a question that I've always wondered about. So for DICOM, we have the conformance statement. Is there something similar for HL7, whether version 2 or FIIRT?
That's a great question. I'd say yes, there is, but you can't generally find that on the software manufacturers' websites. You could ask them and they would probably have it, but it's just, like I said, something that's not made public. And there's a variety of reasons why. A ton of different types of information that you'd see in that. There's nuance in understanding how those applications are populating some of those HL7 fields. But yes, such a thing typically exists because when someone goes to integrate an HL7 interface into their application, they would need to understand exactly how they're leveraging all the different fields within HL7. So for example, maybe a lab system is not populating the patient location because it's the lab system and it's not really the source of truth. You would say, we're going to leave this field blank on the HL7 conformance statement because it doesn't make sense for that particular workflow. So you'd see those things, but like I said, you wouldn't be able to just Google someone's conformance statement generally. You'd have to ask that from them instead. Also worthy to note, because we talked about DICOM conformance statements, we just touched on HL7 and what that looks like. IHE also has their statements that vendors will also produce as they conform to the individual profiles. So that's also a very helpful resource. You can search for that and see what profiles and what actors they actually support. Do check that out. I think it's very helpful for IIPs as they're thinking about how they connect and work with their ecosystems.
Yeah, that's interesting that these statements aren't as readily available as the DICOM conformance statement, but each field is going to be a little bit different. I want to pivot to a different topic a little bit. So, thinking of standards, I remember, not that long, well, maybe it is long ago, but particularly when digital cameras were really hitting the stage, right? Like you had compact flash, you had SD, you had Sony's memstick, blah, blah, blah. So there were all of these memory cards that they were standard, right? They had their own standards, but there was also proprietary nature to it, right? Because certain cards like Sony's, they use their Sony sticks, right? Other companies might use something else, or they would use a compact flash maybe. So clearly there are certain economic benefits and detriments to being more on the proprietary side of these hardware and software integrations or models, whatever you want to think about it as. What do you think about the economics of this, the standards where everyone is using the same thing versus, proprietary? Another example is cell phones, right? Every new cell phone you got had a different plug, and eventually everybody moved towards like micro SD or that kind of thing, right? So there are definite benefits to the consumer. You don't have a bazillion of these old things, but then from the company point of view, you're not a special snowflake, right? Thinking about medical stuff, what do you think of the economics of that sort of thing?
Yeah, no, great question. Healthcare standards allow us to innovate and do compelling things without having to differentiate on a feature that is just expected out of the box. I think if you're purchasing healthcare software, whether it's an EMR or a PACS, there's an expectation that it will just work with the rest of your hardware and your applications that are working within your hospital. If each of those vendors would have to spend the time to figure out, okay, I'm talking with this company's PACS and this company's RIS and this company's reporting engine, and each of those is a point-to-point. I have to negotiate what I'm going to send to this company. They're going to use my proprietary REST interface. I might use theirs. The amount of time and effort, wasted effort to have to do that proprietary every single time for every single hospital, for every single vendor, it's just a tremendous waste. And all the companies recognize that it's really not in their interests to have to, finagle that last mile. If we put one standard together where we all, will interoperate and send data and trigger these workflows in the same sorts of ways, we could focus on building compelling software and not have to, again, worry about that and differentiate on that last mile. It's super important that we make this as easy as possible and not incur that debt of having to connect these various systems together. I guess, one way to think about this, you can't equate a bank to a hospital, okay? And here's what I mean by that. When you're in a bank, there's banking software that are sending transactions to one another, but typically it's one system that is being used at that bank. A hospital, I would look at it more like an entire banking system where you've got, different software applications wanting to talk to one another, all by different vendors. When we're flowing information back and forth, it's very similar to banks sending information from one bank to another, where whether it's this bank or this credit union or whatever it happens to be, we need to have a standard way for communicating those things when we're across different vendors in a rich ecosystem. So it's really important to think really more at the enterprise level. And, even when we're looking at different systems in a department talk to one another, when we look at how different systems in a hospital talk to one another, and then we go, beyond that into HIEs and other bigger systems, VNAs, across state lines and across countries, it's all around how we're connecting these systems together.
Thank you, Brad. So I want to shift the conversation in a slightly different direction. So economics aside, if I know I want to implement standard X, Y, or Z in my hospital, how do I go about doing that? Am I expected to go and to read the standard or profile text, or is that a different way to do this?
That's a good question. You should always start from the top down, right? So I wouldn't come at the problem saying, hey, what standard am I going to use and how am I going to do that? Let's start from the problem space. So let's say you have an EMR and you have a PACS, and you would like to send patient data from one system to another. So you would look at, IHE is probably the best place to start, because you could usually find the profile of the actual workflow that you're trying to do. And then there you're going to learn, okay, for that type of workflow, we would be using an HL7 message, probably an ADT, and probably an ORM message if we're using version 2. So you can read up on those relevant standards from HL7 if that's what you want. But probably where you're going to start would be with your vendors and understanding what is supported out of the box with your software solutions. So you'd look for those conformance statements. You'd look for the API documentation. You'd ask, hey, what standards do you support? Because I'd like to be able to take advantage of them and connect that to my other system. If you're more on a programmatic level or on a message transaction level, and you're thinking about things like, doing an HL7 engine to broker messages from one system to another, that's definitely a possibility. Or a DICOM router if you're routing DICOM from one point to another. But really, your starting point is really, really understanding your use case and using standards as a means to an end to be able to connect these systems together.
The cynical part of me kind of wonders, all right, so they published this DICOM conformance statement, but does it actually do what it says it's going to do? You know what I mean? Like there's so many times where, you'll get something and it says, oh yeah, I can do this, or even take hard drives nowadays. They say 1 million gigabytes, and that's not the gigabyte definition that we all know from base 2 mathematics. It's 1 million. So I kind of have to wonder, do you just take the vendor's word for it? How do you verify some of these claims that they make? And I'm not trying to throw shade on our vendor community by any stretch of the imagination. But, like I said, with the gigabyte example, right? There are ways that marketing can be used to not lie, but maybe not mislead. But if you don't know the definitions of certain things, you may make assumptions that you shouldn't, right? Things like that. How might we encourage vendors to adopt different standards?
It's a good question. And one of the sayings that I remember back probably about even half a decade ago, which was, we have to be vigilant but tolerant. So what that means is, when we're using DICOM and HL7 standards, if they're being used incorrectly, generally it's because we're trying to do something bad or trying to skirt the rules or trying to do something wrong. We're meaningfully trying to solve a problem that maybe the standards haven't caught up to, or maybe there's a misunderstanding in the standards. It's possible, and if we ever find them, we have robust processes to update the standard. But as different applications within that ecosystem, let's say we're putting the wrong field in, or we're using a symbol that we're not allowed to be using, or we're repurposing a field and we're putting some other piece of data in, trusting that the other system will understand what to do with that piece of data. So all of these types of things happen, but generally it's in the best interest of every player in this ecosystem that the standard works according to what the standard specifies. So, the amount of effort, if there is a modality that's producing DICOM objects that have the wrong field set, it has a downstream effect to the PACS, to any other system that wants to, use that information. If we then send it to a VNA, like the problem will really start to propagate. And so we really try to get in there and adjust those and fix those problems. But it's really just a community effort to make this work for everybody, for the entire ecosystem.
Sometimes when you're implementing things the interoperable way versus the proprietary way, there may be a bit of a penalty with increased time to make things work, or maybe a penalty with performance. How can we justify that?
So it can be justified to an extent by the means of how repeatable and deployable would that application be with and without standards, right? So if I were to say, you know what, I'm going to write my own DICOM to disk standard because, I want to take advantage of, some other, technology that makes it faster, or I want to separate the metadata from the pixel payload, whatever that happens to be. If you implement that on your own, then you're on your own, and you can only scale as much that you can scale. So now all of a sudden, if you were to say, okay, well, now I'm going to connect to 20 other vendors' applications, and they either have to conform to my way of doing it, or I have to eventually go back and conform to the way that they're doing it, it doesn't really serve you as a purpose. What would be better is if you have a better way, let's bring that into the standard. And that's, partly why I started to get involved in standards, is how do I contribute my experiences to developing interfaces between different systems to try to make things faster, make things more robust, make things more efficient and effective. The short-term gain, you're incurring a lot of debt down the road for when you actually try to interoperate within an ecosystem. Unless you control all the endpoints, you're setting yourself for a lot of work downstream, for sure.
It's interesting because lately, a lot of the manufacturers for like cell phones, for example, like, Apple, Samsung, Google, they're starting to make their own chips instead of going to third-party off-the-shelf manufacturers. So I kind of see, your answer in that light where, yeah, you can do this. And, chips may not be the best example, but they are moving back towards kind of a more proprietary hardware setup, if you will. And there's going to be certain costs to that if you're not able to make it all work right together. But I do wonder, though, like I know DICOM has working groups and stuff like that so that they can evolve. But what about some of these other standards like, HL7, FIRE, IHE? What do they do to evolve and iterate? And, ultimately, what does that mean for our end users and, the IIPs, and how can they keep up with some of this stuff?
So it's very important that the core interoperability remains in place, meaning that if you were to take a DICOM file from 25 years ago, absolutely, you could open it up today using the same tools that you have today because of that backwards history. So one thing that standards do is really help to ensure that throughout the lifetime of those objects that are being created and shared, they could be understood. All of the SDOs, whether it's HL7 or DICOM or IHE, we all have working groups where we're looking at what change proposals are needed to the standard, what updates do we need to do? Are there new modalities? Are there new, lab instruments? Are there new workflows that we need to be thinking about? And so you can go to DICOM with the DICOM Standards Committee and all of the working groups underneath. Working Group 6 is a great work group to follow in terms of the technical creation and vetting of the standard. In HL7, there are many different working groups. So I've been involved with and used to co-chair the imaging integration HL7 working group. But there are many different working groups like orders and observations and documents and other things that groups of people gather around the world to talk about what updates are needed in that space. And in IHE, similarly, they also have a technical committee as well as a planning committee that meets at least a few times a year, for week-long workshops to develop new profiles and consider any change proposals to what's currently out there, and also to move profiles from trial implementation onwards to final text. What's really important is that these standards, although there's changes that are coming in as the world changes, but we always maintain backwards compatibility. So there's always a means for us to be able to continue to use those existing systems and not sunset. Because honestly, when we think about the world of the healthcare ecosystem, let's say you have a CT unit or an MRI, you build a hospital around an MRI. That MRI, once it's there, is there for a long time. And it's producing DICOM for 10, 15 years. We need to make sure that that MRI will continue to be able to send the data back to a PACS system so that we can use that in the workflows no matter what's happening in the ecosystem. So there's always changes going on. We're always thinking about how do we make sure that we're not breaking anything that already exists out in the field.
If I may ask a follow-up here, Brad. So, for somebody who's kind of just sitting there and hearing these buzzwords kind of fly by, for example, HL7 version 2, 2.3 versus say 2.5, or, FIIRT release 4 versus release 5, or, DICOM. I don't remember what the release or version structure is, but you hear these and you're like, oh, should I be on the latest and greatest? Or, what would you say to that person?
It always goes back to the workflows that you're trying to support. If it's working, there's really no reason to go in and upgrade your version of HL7 to a different version, right? To what end and what is the point of doing that? If there's a real reason, let's say a new standard comes in that offers, better security or enables additional workflows that your current version doesn't support, then maybe that there's a reason. But there has to be a really, really good reason to upend that interconnection between two different applications. Because it's not as if that you can say, well, we're going to upgrade HL7 today. We're not going to see any patients until that upgrade's done. There's real business going on that impacts life and death of what's happening at the hospitals. So while you might, plan a project that could take 6 to 12 months that might consider an upgrade or replace of an existing standard, there's probably more important things to be doing. And really, that's what should be the focus is what are we trying to do in terms of workflows in our hospitals? Standards are a tool to help us get that job done, but they're not the be all end all. The workflows are what's super important. And we use standards to make that real and make that scale and make that efficient and effective.
So how can people get involved? How can our listeners influence these standards? And more importantly, why should they? How would you pitch to them you should get involved in this because it's important? What would you say?
Absolutely. We need you. We need your voice. We need you to participate. We need to hear your perspectives. We need to make sure that whatever we do, we're incorporating your use cases, your ideas, your problems, and helping to address them. The standards bodies are a mix of users and vendors and engineers and architects and physicians. And I think anyone who goes to SIM or RSNA, all these people have such great ideas, and it's so important to contribute back to help set our roadmap to make sure that we're building the things that we actually need them to build. And so it's very easy to get involved. I remember my first start into DICOM started way back in 2012. It was my very first SIM. And I crashed a DICOM working group meeting because my coworker's like, hey, Brad, you got to check this out. This will be really interesting. And I sat in and absolutely loved it. And I was able to contribute, my perspectives. I learned a lot. I gave a lot. And I wouldn't trade that for the world. It's been fantastic. So in order for us to create meaningful standards, meaningful profiles, and really at the end of the day to help your workflows, it would be great to get involved. And it doesn't have to be writing standards, writing normative text. It's about contributing those use cases. With IHE, for example, around the February timeframe, there is a public comment period where the public can go and review the profiles that are in development, and they're looking for feedback on, is the use case right? Is the technology right? Are we addressing the means? Is there something that we've missed? So even just getting in, reading those documents, sharing feedback is a great way to get started. But we're a community, and the community includes you. So definitely please contribute, and we'd welcome any participation from the entire ecosystem, from the entire industry.
So Brad, I want to speak about standards, but different types of standards. So we spoke about IHE, we spoke about HL7, we spoke about DICOM. So the standard I'm looking for here is that everybody in your household, I assume, knows what each of these standards actually mean. Okay, jokes aside, I did want to ask one other thing, Brad. So if somebody actually wants to contribute to these standards, IHE, HL7, DICOM, what is the concrete step they take? A website they go, somebody they talk to? How do they go about doing that?
No, great question. So the pragmatic steps to getting involved is first really understanding where you'd like to get involved, right? So let's use DICOM as the example. We go to dicomstandard.org, and we can look at the various working groups that are meeting. So there's a page that lists all the different working groups. So if visualization is what you're interested in, or 3D printing, or web technologies, or pathology, there's a working group for you. You can read up on the minutes of those meetings. You can see the DICOM calendar when they're going to meet for TCONs. You can reach out to the secretariat and ask to be added to the mailing lists. So you get a sense of what the conversations are happening as part of that working group. And then, if you're ready for the next level, you could go and become a DICOM member. There's similar things for HL7, similar things for IHE. You'd start at those places, find your community, whatever that happens to be. All these working groups have co-chairs, greatest groups of people, very thoughtful, very, from a leadership perspective, they're just great to get to know and understand kind of where they sit in the ecosystem. So I'd say that's probably where you start, is get a sense of the community, visit the website, see what the conversations are, and look for where you jump in. Really easy to get started.
All right. So we're going to print up a bunch of posters. I'm going to have that old Uncle Sam one that's, I want you to join the army, right? Military, right? We're going to have you, though, being like, Brad Genereaux wants you to join the DICOM working group or Standards Association. I think it'll help drive people in. But anyways, what are some final takeaways from the chapter that you wrote? Can you briefly summarize some of the salient points that people should be honing in on for this?
Yeah, absolutely. I think that the most important takeaway, and I kind of alluded to this in the opening, in that when I'm in the hospital, there's messages flying back and forth between all the different systems. And, as someone who is monitoring my applications, who care about these systems functioning, I really need to have an appreciation for how these different systems are talking to one another. So that, for example, if I'm on the CT machine and I'm looking for my patient and they're not showing up, I should know what system is that coming from? What is it, the type of technology that's used from sending one system to another? Is really important just to have an appreciation of what HL7 does for me, what DICOM does for me, what IHE does for me. And so in terms of a takeaway, just understanding it's not magic, that the workflow between these systems have been set up, thought out, debated, and really galvanized into a standard that is reachable, that you can read and actually see what's happening. And you can go as deep as you want to or as shallow as you want to. But these systems are intercommunicating to be interoperable, to really deliver the services that you're looking for. So just reading through that chapter and understanding the technology really goes a long way into understanding how to support that technology, how to take that to the next level. How do you make your clinics more efficient, more effective when you're looking at the entire spectrum of applications within the ecosystem?
Awesome, Brad. This has been amazing. Thank you so much again for taking the time to talk about this chapter.
Simcast has been brought to you by the Society of Imaging Informatics and Medicine. Please visit our website at siim.org for more information and educational content, including webinars and an archive of prior episodes. Please follow us on Twitter at sim_tweets. Thank you to our listeners for your continued support. you.